Hi, welcome to the Olympiad geometry. Let's continue our study on Orthocenter. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe the channel. Here is a problem. In an acute triangle ABC, angle C is larger than angle B. D is a point on BC side, which makes angle ADB to be an obtuse angle. H is the orthocenter of triangle ABD. So you can see that I draw the perpendicular line of BC from A, and I draw the perpendicular line to AB from point D, right? And these two lines intersect on point H. That's the orthocenter of triangle ABD. F is a point inside of triangle ABC. F is a point inside of triangle ABC. And on the circumcircle of triangle ABD, F is a point inside of triangle ABC and also on the circumcircle of triangle ABD. Prove that F is the orthocenter of triangle ABC if and only if HD is in parallel with CF and H is on the circumcircle of triangle ABC. So if we check this problem, and we can break the target to be two. The first one would be if F is the orthocenter, right? Then we need to prove that HD is in parallel with CF and HABC are cyclic, right? That's the first half. And for the second half is that if HD is in parallel with CF and HABC are cyclic, then F is the orthocenter of triangle ABC. Right, so let's check on the first one. F is the orthocenter of the triangle ABC, so we already draw the perpendicular line, the altitude of the edge BC, right, the perpendicular line to the BC, and we also can draw the altitude on the edge AC, which right. So let's call this point as M, this point as N, so this is F. Okay, now we know that F is a orthocenter of triangle ABC, and we want to prove that HD is in parallel with CF and H is on the circumcircle of triangle ABC. Because F is a orthocenter, so we know that CF is perpendicular with AB, right? And we know that HD is perpendicular with AB because H is orthocenter of triangle ABD, right? So this is 90 degrees, and CF is perpendicular with AB. That means CF is in parallel with DH, right? So we connect DH here, we connect CH here. So we just prove that HD is in parallel with CF. Now we want to prove that HABC are cyclic. Remember that when we have the orthocenter here, we connect the one vertex with the orthocenter and we extend it, intersect with the circumcircle of a triangle, and we find that the distance from the orthocenter to the foot equals to the intersection point of the this line and the circumcircle, and the distance from that point to the foot are equal, right? So we just need to prove that. Because we want to prove that H is on the H is on the circumcircle of triangle ABC. So we just need to prove that H is the same point, right? Okay. So to do that, we just let me see this way. We want to prove Fm equals to mh, right? Because the distance from the intersection point of altitude to the circumcircle of triangle ABC to this point equals to the orthocenter, equals to the distance from orthocenter to this point, right? That's a property of the orthocenter. So we just want to prove this one, right? We want to let's see this way. We want to prove this one. Fm equals to mh. The first thing we know that because Bn is the altitude of AC and Am is the altitude of BC, right? F is the orthocenter, so we know this angle equals to this angle. This one equals to this one. And we already know that A, B, D, F are cyclic, right? Because F is a point inside of triangle ABC and on the circumcircle of triangle ABD. So A, B, D, F are cyclic. That make angle DBF equals to angle DAF, right? Which means we have angle DAF equals to angle CAF. And we know that AF is perpendicular to DC. So we know that dm equals to mc, right? dm equals to mc. This one equals to this one. And we know this is 90 degree, this is 90 degree, and because CF is in parallel with DH, so this angle equals to this angle, right? So CF in parallel to DH, we know that angle FCD equals to angle HDC. So in the triangle DMH and the triangle FMC, we already know this angle equals to this angle, and this side. So basically, the triangle DMH and the triangle FMC are similar because the angles are equal, right? And because DM equals to MC, so we know that triangle DMH is congruent to triangle CMF, right? These two triangles are congruent, which means FM equals to MH, which means H, A, B, C are cyclic. Right, that's the first part. For the second part, let me just redraw the figure so we won't be distracted by the auxiliary line we draw on the previous problem. So let's just H. Okay, now we know that HD is in parallel with CF. We already know HD is perpendicular to AB. So we know that if we just find the altitude from AB side, then this line, let's call it CK. CK would be the altitude on the AB, right? So we know that CK is in parallel with HD. Right? And we already know that HD is in parallel with CF. That is saying the F point is on the CK, right? And we have the conditions that H, A, B, C are cyclic. we want to prove that F is the orthocenter. Basically, we want to prove that F is this point, right? Okay, we just know that F is on the CK, and we know that H is, and we know that H, A, B, C are cyclic, and we know that F, A, B, D are cyclic, right? So what H, A, B, C are cyclic can tell us? That is saying, if we find this point, let's call it L, right? The orthocenter of triangle ABC is L, right? And this point is still M. We know that LM equals to HM, right? LM equals to HM. And we already know CL is in parallel with DH. That is saying triangle LMC is congruent to triangle HMD, right? These two triangles are congruent. That is saying this and the DM equals to MC. So this segment equals to this segment, right? DM equals to MC. And based on DM equals to MC, let's connect DL and connect CH, right? We know that LM equals to MH, DM equals to DM. This is 90 degree, this is 90 degree. That means triangle DML is congruent to triangle DMH, right? Which means DL equals to DH equals to HC equals to CL. Okay, now we get DL equals to LC. Okay, based on DL equals to LC and this angle, the angle DLM equals to angle CLM. So we know that angle DLA equals to angle CLA, and DL equals to LC, AL equals to AL. That is saying triangle DLA is congruent to triangle CLA, which means angle DAL equals to angle CAL, right? Angle DAL equals to angle CAL. This one equals to this one. And we already know L is a congruent, L is a orthocenter, so we connect BL. Because L is an orthocenter, so we already know that the angle CAL equals to angle LBM, right? Equals to angle LBM, which means angle DAL equals to angle LBM. Look at here, DAL equals to angle LBM. That is saying ABDL are cyclic. Okay, notice that for the circumcircle of triangle ABD, right? For the circumcircle of triangle ABD, the line CK has only two intersection points with the circumcircle of triangle ABD. And one is inside of the triangle ABC, one is outside of the triangle ABC. The inside one is a point L, right? And we already know that F point is inside of the triangle ABC, and also FABD are cyclic. And now we know that ABDL are cyclic. That means F is L, right? F and L are the same points. So that is saying F is orthocenter because L is the orthocenter of triangle ABC. Okay. So for this problem, it's not a very difficult one. Just we need to figure out how to draw the auxiliary line based on the CF is in parallel with DH. We can just prove that DC and FH equally divide each other, and then everything just come out. Okay, I hope you like this video. See you in next one. Thank you.